All right, guys, I haven't done this before, so I'm going to give it a few minutes before we get started. All right, I guess I think I'm going to get going. It's going to be weird. I'm just talking to myself in a room. So if you have any questions or anything, you can either do it in this live chat, I think, that exists, or you can ask it in Slack. Looks like we got a couple people on. Hopefully some others are joining later or will watch the video. That's one of the reasons I'm doing it this way instead of just live Google Hangouts where we'd be able to talk to each other. But the chapter that we've been working through, or looks like a lot of you are working through right now, is the React and Flux chapter. And this is really introducing a much more complex concepts even than React was on top of it. And that's because it's trying to introduce a concept about how to deal with data in larger applications. When you have something very small and simple, it's easy to manage how your data is changed and transformed. But when you start getting into large applications, then there's a lot of complexity in managing your data. And I think a good example of that is brought up at the start of this cartoon intro to Flux problem, which is Facebook. Facebook has a lot of information, a lot of data that they're trying to manage when they're building their Facebook application. And they have to make sure that all of that data is up to date and correct from different places that can update that information. So the problem that they were encountering a lot of that helped them adopt this concept of Flux was what they called their notification bug. I don't know if anybody ever noticed this. I still think that they've got some issues with it that they could work on. But the challenge was you go to Facebook and you've got your notification up in the top corner that tells you, oh, you've got 3 new notifications, you know, stuff has changed. So you'd click on it, you'd see some notifications, maybe, and then you would navigate around and suddenly it would tell you, oh, you've got more notifications there again, 3 notifications, and you click on it and there'd be nothing there. And then okay, there's nothing there, but it goes away for a while and you navigate around Facebook and it tells you you've got notifications again and you go back to click on it and there's nothing there. And the reason this was happening was because they have a lot of different data and models of data that they're trying to update. You know, you can imagine all of the data sources that are going on at any point in time in React. They've got updates that you're making to your stuff, status updates. They have any other interactions that you have with people. Have you liked posts? Have you commented on posts? Have you asked it to not show you posts like that anymore, or posts from that source? Along with continually checking to see if any of the people that you follow or that follow you have had updates, and do I need to let you know about those updates? And when you're dealing with that sort of complexity, it can get really hard because the way that you update all of that, if you imagine your data model as just being a big pile of data, I don't even know how to describe it. Imagine a spreadsheet, right? Although in reality, it's a little different, but it looks a lot like a spreadsheet. And so there's not really a visual layer to that, but that's not the way that you interact with the data on Facebook. That's not how you make a post. You don't go into a big spreadsheet of posts, add a new row at the bottom, and put your comment in there. Instead, you have a view, this UI layer, that lets you interact with the data and make changes. And in that UI layer, you make a change, you add a post, or you like somebody's post or comment. And then that UI layer, which in this is called the view, then needs to pass that information down to the models so that the models get updated correctly. And now when you reload the page, or when somebody else accesses those models, they want the new updated thing. They want their post to now be liked by you because you liked it. And that needs to propagate across everything. Now the challenge here is there's a lot of this sort of two-way communication and binding that was going on, where views were updating models all over the place and different types of data models. So you've got, oh, I need to update the model for liked posts because I just liked something, but I also need to update a model for adding a comment because I added a comment to the post. And those might be 2 different models. So your view is sort of dispatching these actions to all these different models. And then the traditional way for the view to get notified that it needs to change and add that onto it, like, how do I show that I liked this post? What do I do to show that information? Is for the model to tell the view, hey, I just got updated. Go ahead and change and update with the newest version of this model. Here's the changes that just happened. So that leads to this very complex interaction going on where you have views updating all sorts of different models, and the models are telling the views, each view sort of independently, hey, you need to re-render. which when you think about it from a, oh yeah, I want the models to tell the views to re-render, and I want the views to update the different models, it makes a lot of sense. But when you look at all of these connections, you can quickly understand how it would be hard to manage that and very easy to make mistakes or to miss something so that everything doesn't stay in sync the way that you want it to. And so, for example, if we go back up and think about that notification bug that was brought up at the beginning, it's pretty easy to see how maybe this view, you click on it and it tells it to update. The view gets sort of optimistically updated. Oh yeah, you clicked into here, so we're not going to show any notifications anymore. And maybe it even tried to send something back to a model to update it, but it didn't get the model correct. And so later on, it gets another push from the real model saying, oh, there's some notifications that you're missing. And that can cause this complex disconnect where bugs can be really hard to trace down, because where is it that a view didn't send something to the model to update the model? Is it that a model is out of date and it's telling the view to render that way? Is it that a view is somehow disconnected from the model, so it's not getting the latest version of the data that it needs when it renders? Very, very hard to debug, especially when you get into larger scale applications, larger scale programs. So that's what Flux was designed to solve. And what I'll say, and I mentioned it at the start of the chapter, right, is that there's a lot of different implementations. It does a quick introduction to Redux and MobX and then Flux as well. And there aren't really any applications that use pure Flux that I've encountered. I mean, there might be a few, but Flux as a concept is much more important than Flux, the exact way that they built it. By far the most popular implementations of any sort of data binding like this are Redux, and then MobX has gained some traction. But I would say Redux is by far the most popular version of data binding in this way. So don't get hung up on trying to learn the details of Flux. I would say that if just learning the concepts, the ideas of how it works is important. And then if you really want to build applications using this approach, Redux is probably the one to learn more of, or maybe MobX if you prefer that approach a little more. So with that said, that's why I think it's really important to go over the concept of what Flux is trying to solve before you try and implement it. So some of you have already been in this chapter, and I imagine that the Flux code is pretty complex, pretty challenging to understand. I don't think necessarily it did a great job of explaining what's going on or why it's even trying to solve a problem in this chapter. And so I wanted to step back and, instead of digging into code so much, talk more about the concept of Flux, or the concept of this one-way data flow. So what you could call this model up here, or this, I say model, and here's model in it, so it can be a little confusing. What you can call this approach to building an application is commonly called two-way data flow or two-way data binding, because the views are updating the models and the models are updating the views. So you've got this two-way data binding between the two, so that if a model ever gets updated from some other approach, like this view updated this model, then this model should update any of the views that are bound to it. But if this model or this view changed instead, it should go the other way. And if the model changed, it should update the view. So it's sort of bound in both directions, where it doesn't matter if it's changed in a view or changed in a model. You want them to be bound both ways. And one of the big changes dealing with stuff from a Flux perspective is to try and make it's a one-way data binding, where the views update the models but not directly, and then the models just update the views when they change. So instead of both of them changing in each direction, it's sort of this one-way flow. And this will make sense as we go down through this tutorial or this intro more, but what happens, the basic flow is a view dispatches an action, and that action might be add a new note, or delete a note, or mark the note as done. Those are actions that it would dispatch. And with that action, it would include the information that you need in order to perform that. So it might say, add a note, and here's the text of the note, or the task in the way that our data model exists right now. You might say delete a note, and here's the ID of the note that I want to have deleted. So that's the action that gets dispatched, that the view creates. And then the dispatcher takes that action in a Flux model and looks for any store that is subscribed to that action in some way. And it says, oh, these stores need that action because they need to update based off of that. So that dispatches the action, which is the only way to actually change your data model, the store. And then when that store changes, it says, oh, update the views because the store is different than it was before. So it's an attempt to have this be more of a one-way loop where stuff can't go directly back from a view into a store and a store to a view. It all flows in this circular fashion, which is really, really powerful in terms of being able to reason about what's going on in your application. But it takes a little bit to understand why and really to understand what's going on here. I've worked with a model like this for a couple of years now, and there's still bits and pieces that I'm learning over time about how to do this in the best way. So this is where, like I said, I think this tutorial is great. It's going to break it down more and more. So we'll go back up here. We've got our view, action, dispatcher, store. These are our actors, if you will, in what we're building out. So let's build that out into more detail. Here we've got our action creator. The action creator, their job is just to create these actions that the dispatcher is going to handle. I love this tutorial. It says, think of the action creator as like a telegraph operator. You go to the action creator knowing basically what message you want to send, and then the action creator formats that in a way that the rest of the system can understand. So you might go to him and say, message create, or in our type of application, note create. Or you might go in there and say notes delete as actions that we would be creating, and you give that action a payload as well. And then the action creator will take that action type and payload and convert it into whatever format is needed for the rest of this workflow. But one of the great things about having this action creator, especially when you're just learning an application, is that by having an action creator that sort of manages all of the actions for your application in one place, it can make it really easy to go there and look at everything that can happen in your code. So right now it's sort of convoluted. If we were to go and try and figure out what different types of actions can take place in our code, it's hard to find them all. Well, we can, you can edit a note and you can delete a note, but we're a little lucky that everything's at this app level in this one. You can add a note, but we're just sort of having to parse out what are the actual actions that take place by stepping through the different portions of code. And in a more complex application, all of them may not exist in the same component. The notes may have some actions on it. An individual note may have some actions that are attached to it that change the state of your application. And that makes it really hard to see all of the possible transformations that can happen in your application in one place. Whereas when you have an action creator that knows about all the different types of actions that your application can do, that gives you one unified place to go look at. Oh, here's one thing to look at that'll give me everything that I can do in this application, which is one of the great benefits of this type of approach. Now, one of the drawbacks is those actions may be not really strongly related. And so you may want to break stuff down a little bit inside of your action creator area to give it some logical separation, because some stuff might be related to notes, but you may have some things that are just related to changing the theme of your note-taking application so that people can change the background colors and the colors of the notes. Not really related, but all different types of actions that can take place in your code. The next step in the Flux architecture, if we go back there, I'm going to open this up in a separate tab so we can leave it up, I think, if it'll let me. There we go. So I'll leave this up over here. The next step is the dispatcher. So we've got this action creator layer, and all the action creator is doing is it knows all the different types of actions and how to format them the way that the dispatcher expects. So we may give it actions that are formatted useful to the views because it makes sense from a view perspective, and it may need to do some manipulation to change it so that the dispatcher understands the form of the action. And what the dispatcher does is, good, I hope so. So what the dispatcher does is it has a list. It's really doesn't care that much about the action creator, but it can get actions sent to it from the action creator. The dispatcher knows about the different stores, the different pieces of information in your application that need to know about changes. And this goes back, again, using this analogy of an old switchboard. The dispatcher says, oh, I just got a create action or create note action. And the things that need to know about that are I need the note list to get or the note store to get notified so that I can create a new note. But maybe we have something else that needs to be notified of it as well. In our case right now, we don't have anything else that has to be notified immediately. But there might be another store that needs to be notified when you create a new note. Maybe we have if you've done any or seen this on other sites, and some of the people who have done Rails will be familiar with this, maybe you have some sort of toast message or message at the top of your view that you want to pop down that says you just created a new note as sort of a notification. So maybe we have like a notification store, and that notification store needs to know when a new note is created because you want to pop down a little notification in case, for example, Facebook, in case you're on a different page and now you get a little notification at the top that says, hey, somebody commented on your post. Do you want to reply? That's not the exact same store as the notes store. And that's where this dispatcher comes in handy because he may say, oh, I got a new note or create note action. All right, I need to dispatch that to the notifications store and to the notes store. So he's got these connections of the stores basically tell the dispatcher, whenever notifications of this type come in, I want to know about them. And then the dispatcher does that dispatching and hooks them up. Now, I'm being a little broad there when I say it's just sending it to those, because it is true that in reality for Flux, like pure Flux, it would actually dispatch the action to every store. So it's not just stores that say, I'm interested in this action. It sends it to all of the stores, I believe is the way it works. That's the way it works in a Redux type thing, but there's only one store in Redux. All of your data is stored in one place. And one of the other great things about this dispatcher is it's doing all of this synchronously. So there's no possibility that you end up in an inconsistent state because it tried to update one portion of something and was trying to update something else. Something else was trying to update that portion at the same time. And they changed the state in between each other. And now we're sort of inconsistent. Instead, since the dispatcher is the only thing that can send these notifications to the stores to update, he can control, or it can control the order of them. It can do it synchronously, and then you don't end up in these inconsistent states between them. So now we'll get to the stores. Now I talked about, I said that the stores only subscribe to actions that they care about, in a sense. Like oh, maybe the notifications store cares about new notes and the notes store cares about it. And this is where it's not exactly the way it works, but pretty close, because the store holds on to all of the information that it needs for that portion of the state of your application. And the only way that you can change it is through dispatchers. I'm going to read this just so I don't get too far off the way it was described here again. Right. So to request a state change, if you want to change the state of your application, aka add a new note, you have to submit an action via the action creator dispatcher pipeline. So you can't just directly change the store. There's, unlike an object, and if we had a property on an object of name, and if you want to change your name, you just do, you know, object.name equals a new value. You can't do that on the store, and that's intentional. That's because we want to enforce this unidirectional data flow where your view dispatches or creates an action using an action creator, which dispatches the action, which updates the store, which updates the view. If you could just change values directly on the store, you would break out of that model, because the view would be updating the store, or something would be updating the store directly, and you wouldn't get the benefits of this sort of controlled data flow. But as I mentioned, the sort of weird part about Flux stores is that the dispatcher actually sends each action to every store. It dispatches it to every store. And so how do you handle that if the store is getting actions it doesn't care about? So let me think about it. We'll go back to our example we were talking about. You can theme your, let's say we can theme our note-taking application, and we have a dark theme or a light theme, and that's part of something you're storing. And so somebody changes to the dark theme. Well, that's going to get dispatched to the notifications store and to the notes store, but they don't care about that at all. Why are they getting notified? Or what do they do with that? And that's where inside of the store itself, there's a switch statement that is just looking to see whether or not this is an action that it cares about at all. So you could think of it as, if you want to think if blocks instead of switch, you could have a top level if that says, if this is an action in the list of actions I care about, then we're going to change my state somehow. Otherwise, we're not, and don't update me at all. I don't care. And then inside of that if block, you could check against each one of the different actions that you care about. But you can do that same thing with a switch statement, where inside of the case switch statement or the switch case statement, you just check for the actions that you care about, and then your default behavior, if none of them match, is to ignore that action more or less. So the last thing that happens is, let's say the stores get updated. In this case, we have created a new note. So it's updated our hypothetical notifications store and our notes store. Those stores, the views have registered themselves with the stores, or registered the stores inside of the view to say when a change happens to the notes store. And the things that would care about the notes store would be the app and the notes, maybe, or maybe just the notes section. But what you would do is say, when something happens to this notes store and I'm a view that cares about it, then tell me that that store changed. And once that happens, so now the store has changed, we've added our new note to it, and it notifies the views, hey, I've changed. If you care about that, do something. Now the view can go, oh, you changed? All right, let me read the new state of the store and re-render based off what's in there at this point. So that's where the notes component would go, oh, the notes store changed. All right, get the notes now and re-render all of my notes because something about that changed. Uh-oh. All right, so now we can go down into that, because I think that's what this next section dives into, is the controller view and the view. So the views are in charge of taking the state and rendering it out for the users, as well as accepting user input. The view is a presenter. It isn't aware of anything in the application. It just knows the data that's handed to it and how to format the data into output that people understand, in our case via HTML or React components. And the way that happens, the way it knows when the data has changed, is this controller view that's managing the store and the view. So the store says, hey, something's changed. And now the controller view collects the stuff that it needs, passes it down to the view so that they update. So we'll walk through the example that is in this, this tutorial. And then if somebody has a question or they want to talk through another one, I don't have one sketched out, then we can do that as well. So let's imagine this. It says setup. First, there's the setup, application initialization, which only happens once. So stores let the dispatcher know that they want to be notified whenever an action comes in. That's what we were talking about before. The dispatcher needs to know what stores exist, essentially. Now remember, in Flux, it dispatches every action to every store. So you don't need to register and say, ooh, I care about these specific actions. You're just saying, oh, I exist. Let me know when something comes in and send it off to me. So then the controller views, and these are the things that this over here that do rendering, these hook up to the stores as well and say, okay, store, when you change, let me know. So this is saying, oh, when an action comes in, the store wants to know, and when the store actually changes, let this dispatcher view know to update the views. So when the store gives the state to the controller views, they pass that state along to their child views, right? That's, all right, here's the state, you go into the child view and you're gonna render. And that's really the setup step, if you will. So now we're all set up with a data flow in terms of when the dispatcher gets some sort of action, it's going to notify the stores, and when the stores change, they're going to notify whatever data views or controller views, I guess is the term being used here, exist that care about the store, that specific store, and that's going to update the actual views in the application. Now, the one thing we haven't done though is that up to that point, we don't have a way to actually get something to the dispatcher, which is the next step. So let's do the data flow now. And we've got all of our setup in place, so stuff will get notified the way we want them to. And now the view is what tells the action creator to prepare an action. So this is the data flow that's actually going to happen whenever something changes in a Flux type application. So in this case, our view would be like our Kanban application, and we tell it, create a new note. That's the action that we were telling it to dispatch. So we notify the action creator, hey, this is the create note action, and the task in this case is new task, but eventually maybe we'll allow it to have something different, I don't know. So now we've got our action creator. We're all ready to go. It formats this action in a way that the dispatcher is going to understand. And it says, okay, the dispatcher needs the task, it needs this action ID, it expects it in a specific format. We're all ready to go. Here you go, dispatcher. Now it's your job to notify all the stores. So the dispatcher is going to take its action. And the dispatcher says, ooh, every store that's registered with the dispatcher, send it off and tell it, we want to create a note with a task, new task. And that'll be every store. Now in our like hypothetical type application that we've just built, we have maybe 3 stores, right? We have the notification store, we have the notes store, and we have the theme store. So that's the state that we've gotten to. Now the stores have this action, and each one of those 3 stores in our Flux type application is now going to look at that action and see if it does anything with it. So the notifications store says, oh yeah, I need to mark this as the text of, I need to create a notification. The notification will be a new note was created with task of new task. So it puts that into the notifications store, and it knows how to create that and set that state the way it needs to. And the themes store looks at this task, this create note that got dispatched to it, and it says, I don't care about that. That doesn't change the theming at all, so I'm not going to do anything. And the notes store looks at it, create note. Yep, I need to add another note to the list of notes that I have, and I've changed as well. So 2 of our 3 stores have changed in that model. Now that we've changed that data in 2 of the 3 stores, those stores let the controller views know that their state has changed. So at this point, they notify the controller view, hey, my state changed. Something is different about it. Now, if there's a controller view that cares about theming, it doesn't get notified that the state changed because that store didn't change. But the notifications one and the notes one is both going to get notified. Once the controller view has been notified of that, it goes back and says, okay, thanks for letting me know something changed. Give me the latest data. And the store returns the latest data to it. So it gives it back the notifications, the new notification for that notifications view, and the notes for the notes view. And those are used for different things. Maybe the notification is a little pop-down that comes down from the bottom, or maybe it's a toast type message. For anyone who's not familiar with what I'm talking about when I say toast, let me find a quick example. This should work. Let me see here. I don't think they call it a toaster in here, but I think they call it a snack bar, but I've typically heard of it called a toaster because it pops up from the bottom like that. So that might be like a notifications view. And now that this controller view has the new data, it tells its actual views, okay, go ahead and re-render with this new data. Add the new notes, pop up the notification that we need, and the state of the application has changed. So that's really the flow of data through this Flux application. It's this one direction of flow that just keeps going around and around. But some of the great benefits you get from a model like this is it's very easy to know here at the action creator level what types of actions exist in my application. So since this thing has to be able to pass through every type of action that can be created, this guy knows all of the different action types. That's awesome because you can get a very broad level understanding of an application from one place in it. You also have the huge benefit of this communication model where the dispatcher knows about all the stores and can tell them to update or can dispatch the actions to them so they know whether to update. And instead of the views updating models and models being able to be updated from somewhere else in some way that the views won't be able to know about, the models and views are only connected through this controller view that's subscribed to events from the store so that, oh, the store has changed. All right, I know I need to do something about it. Again, this is one of those concepts that when you first encounter it, like in our application that we have so far with our notes, we don't have a ton of complexity. There's not a lot going on there. So you don't immediately see the value of something complex like a Flux data flow. But I can give you a much better example of a type of application that would benefit from this. And in my case, I'll go ahead and just use one that we built since I haven't talked about it a lot. We used Redux, but Flux is very similar. We built an editor, if you will. And I'm going to pull up somebody else's editor, which is similar, so that I can talk about it in a similar fashion. To actually create an account for this, I may have. All right. So we have an editor a lot like this Canva one that we've sort of built. And I can talk here about all of the different types of events and actions that are being dispatched when you make changes. So let's start off even with something simple. We're going to move this text around a little bit. So we want to reposition it on the page. So as I move that, what's happening, I don't know what's going on in Canva, but in our version of the application, there's a lot of different events that can sort of happen there, because you've got events about, oh, this text has moved to a different position. Dispatch its new position to the UI, or dispatch its new position to the store, the action that the position has changed and that we've moved. And now that'll update the store for what cares about it. And that'll update the views. And some of the views that might be interested in that data change are, you'd think, oh, it's just the only view that matters is rendering of this text on the page. But other things that might care about it are the rendering of this whole page, because you notice we just got this dashed line along the left side of our page here because of some sort of, it says, oh, it aligns to this point on me now, so let's sort of show that. Well, that's another view that can be subscribed to changes and get updated and change its state. Other things that it allows you to do is, since you've got this very controlled one-way data flow, is when you want to undo an action, I move this over here, and now I want to undo that action. You know exactly what action got dispatched to move your text to a different position. And so to undo that, all you have to do is undo the changes that came from this one action. If you track that in your stores and you say, oh, this was the action that made the change, and now we dispatch an undo action through here, we can say, ooh, undo the latest action, which was moving the text box. That's really easy to do, to dispatch that sort of undo of that. And then there's a ton of other areas that are subscribed to this. So in our application, again, okay, now I'm editing this text area. Well, that seems like I didn't do much, but I dispatched an action to say, edit this section. And in ours, you've got a banner up at the top as well that is the controls. And that control is subscribed to changes to the store. And now it knows what type of thing is being edited and what type of controls to show up here, because you'll have different controls when you're showing an image versus text. And those can all be really hard things to coordinate if you're doing it without this unidirectional data flow, because if you're trying to manage something complex like that without it, you may be constantly checking, ooh, what controls were on there before? Do I need to change them? How do I know that the controls got updated? When you change any of these controls and change some positioning, let's change the size of the font, or let's change the spacing in some way. That can be really hard to make sure that I changed it up here and it gets updated here, and anything else that needs to change its position based off that also shifts. Whereas again, when you have this sort of one-way data flow, all of these guys can just be subscribed to the data model, get updated when it changes. All of the stores that care about it are going to get notified of that event, because remember, stores don't get to choose which actions they get notified about. They get notified about everything. And so then you just need to subscribe in the right stores to changing what you care about and changing the values. Whereas if you were trying to manage that complex interaction between all of these without some sort of one-way data flow, it can very quickly get complex and hard to follow. So Randell's asking, if a note moves, you have to think about the note moving to a new location, the old location no longer showing that note, and the entire page showing the new layout of all the notes. Yes. So when we get to, let's go talk about sort of the model for what we're, wow, I opened a whole other tab. All right, fine, let's do that. Let's talk about the model for what we were thinking about originally, right? Is some sort of Trello thing. What do I have here? I don't know if I have a separate Trello account or if it's just linked to Google. Oops. All right. I don't care about this. So let's assume I have a Trello account here. I think I do. All right. So Trello is a great example of that. Each one of these boards might be its own data model or store. So maybe you have a store for the basics board, at least in a Flux architecture, this is the way it would work. Remember, in Redux, it's a little different because there's actually only one store in Redux, and what you do is subscribe to subsections of that store to get updates. But in Flux, you may have different stores. So maybe there's a basics one and there's an intermediate one. And if I move this welcome to Trello over from basics to intermediate in the UI, what I'm seeing is a change in the UI. And what might be happening in the Flux model is it creates an action that says move note, and it's then the details of that might be move note from basics to intermediate. And that action is going to get dispatched to every one of the stores, maybe the basics store, the intermediate store, the advanced store. And when it gets dispatched to the basics store looks at it and says, oh, this is a move note action. Do I care about that? Oh, it's moving from me. Yeah, I care about that. I need to delete this note from my list of notes. And the intermediate store is looking at it and goes, oh, this is a note action. Do I care about, or move note, do I care about that? Oh, it's moving to me? Yeah, I care about that. Add this note to my list of notes. The advanced store might be looking at it. Oh, this is a move note action. Do I care about it at all? No, I don't care about that because it's not moving from me or to me, so it doesn't matter. And then you may have, oh, the whole board. Now that we've sort of updated the stores, right? Now what cares about it in the view model? Well, the basics cares about it because it wants to render all of the basics items. And so this is subscribed to the basics note store, and that changed, so it's going to get updated. And the intermediate one is subscribed to the intermediate note store, so it might need to be updated. And maybe there's something up here elsewhere that needs to be updated as well. Like I said, maybe there's a toaster message that pops up saying you moved it over. Or maybe this whole notes application needs to care about it because it needs to change the layout when that moved because it takes a different amount of space. I don't know exactly. I'll have to double check. I cannot remember off the top of my head the way that the stores are structured when it comes to the boards in our application, but you could imagine it being built like that. One of the challenges with building it like that is you want to be able to add different columns here fluidly, and Flux doesn't really give you a fluid way to do that. It expects to know what the stores are when you build the application. So you would probably build this out in a different way instead, where you would have a store of all of the different types of boards that you could have, and that would just be your board store. So you could add more boards to that, and then inside of that, or then you might have a notes store that was separate but related. That way they're dynamic, because you want to be able to, for the parts that you want to be dynamic and be able to add stuff to while the program is running, you don't want to have a separate store if you want to add another one of those types of items. So in reality, it's not going to be built that way, but talking about it, you can imagine it built that way, especially if these were hard coded and we don't add other columns into our list or other ways to structure it. So what I'm hoping is that this is going to be a big help if you have started in that Flux chapter, or even if you haven't, or if you made it through. This really helps explain the reason for having a model like that and the data flow. If you really like this code cartoon and the way it explained it, there's a few others up here by Lynn Clark as well. Another one that goes into Redux. And this is, you can imagine it as a follow-on to the Flux one. So I think it's best to read the Flux one first and go through it, because the Redux one sort of talks about it the same way, but Redux works a little bit differently because it gets rid of the separate concept of a dispatcher, and it just sort of embeds that into the stores, if you will, and then it also makes the store a single store, so that you don't have separate stores. You only ever have one store with separate levels of state inside of it. Again, if you really are getting into building React type applications, I recommend you try and learn or go over this Redux one. There's also a really good video, very deep, very quickly, which is the biggest challenge to it. But there's a really good video from the guy who helped create, or I think really created Redux, on Egghead.io. That's free, getting started with Redux. And this walks you through the concept of how Redux works. So he's got broken it down into very small videos, and you basically build your own version of Redux. Again, this is dense. I've tried to watch these videos. In fact, I've watched a good number of them, but when you first watch them, there were several of these videos I rewatched 3, 4, 5 times to try and understand what was going on, because there's a lot of complexity to it. But this is all of this Flux, Redux, all of this that we're talking about right now, they're really ways to help you scale your application so that you can build something that is larger. And they're most important when you're building applications where a lot of different things are interacting and changing data all at the same time. If you only ever have one thing that changes a piece of data, it's not as big of a deal. But when you've got a lot of different things that can change your models, you need to have a way to control how stuff gets updated, how those models get updated, and make sure that it's really it's hard to say. I said control, but you really want to have a controlled flow there where you know what's going on and you don't end up in an inconsistent state. That's one of the biggest things that a Flux or Redux model gives you, is creating this very consistent flow of data through your application. That was really what I wanted to cover today. I'm thinking that on Tuesday we'll now go through that Flux chapter. Hopefully, after having talked about this at a higher level, it'll make more sense to the people who haven't gotten into that chapter yet. And for the people who have already gotten in there, let me know if this helped clarify some of the concepts, made more sense or not. Since there's another hour in what would normally be our class time, what I'm going to do is I'm going to go ahead and end the video and stop that, but I'll be online, sitting here, ready to help anyone who has any questions or is stuck on something. If you want to help work through something, we can work through that for the next hour. So feel free to ping me. I'm just going to be sitting up here working through some stuff. And then that, I'm going to get going, and have a great day. I hope everyone stays warm. Bye.